Hey everybody, Mr. Kirkwald back here for another week of distance learning. So, Monday, the 27th today, we are going to be going into the April 27th folder. We have a couple of things here. You'll see the video that you're watching right now. Then you've got wave on a string. We're going to need this today. And we've also got properties of Waves Lab Part 1. Tomorrow is going to be Part 2, but today we're going to do Part 1. So, if we open up Wave on a String, I've got that loaded here. If we open up Properties of Waves Lab Part 1, what we're going to be doing is we're going to be using this game in order to fill in the questions here. So I want to go through how this is going to look for you today. So for Properties of Waves Lab Part 1, we are going to be looking at how all of our vocabulary words that we learned about last week, how do all of those relate to one another? So the first one that we're going to look at is how amplitude and wavelength are related to each other. So we're going to be changing the amplitude in the game 4 different times, pause, and measure the wavelength with a ruler. So let me show you how that's going to look. So what I did here, we'll restart everything, there. So this is how it's going to look when you first go in there. We're going to change a couple of things. We're going to change it to oscillate so that it's moving up and down. I'm going to pause it. We're going to go to no end, so the wave just continues to go. If we had it on a fixed end, what's happening is the waves are coming back and forth, and that's going to mess up our results. So we're going to say no end, goes out the window there, and then I'm just going to turn on everything here. So 1, 2, 3, so everything's here, ready to go. So what we're going to be doing is we're going to change our amplitude. So I can change it by going like this with the slider. I'm going to leave it at 75 since that's the first one there. So on my WaveLab, our amplitude was 0.75. And then I need to measure the wavelength here. So what I'm going to do is I'm going to have this go, 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 and then I'm going to hit stop. I like to do it in slow motion because I feel like it gets a little bit, it's a little bit easier for me. And then I'm going to take my ruler and I'm going to see how far it is from the top of one wave to the top of the next wave. So I'm going to go here. I'm going to start at 0, and then I can actually just kind of move it down like this. So I see it is from the top of this wave to the top of this wave. I've got 1 centimeter, 2, 3, 4 point. Let's see, they're divided by 1, 2, 3, 4, 5. So that's 0.2. So 4.2 centimeters. This is 0.2, 0.4, 0.6, 0.8, and 5. So in my lab, I'm going to say 4.2 centimeters. So you can actually just copy that one down. We just did it for you. Congratulations. Then you're going to change your amplitude to something else. So I'm going to say, well, we could just go to the extreme and do 1.5. And then I'm going to hit go. And I'm going to let it go up and down for a minute. So that way we have the correct amount of waves. And then we're going to hit stop. And then you're going to measure here. Did the wavelength change? In your properties of waves, you like 1.5. You're going to measure that wavelength from the top of one wave to the top of the next wave and write it in there. So you're going to complete all 4 of these. And then I want you to go back and answer this question. Does changing the amplitude actually affect the wavelength? Yes or no? That's all you need. For our second one, does amplitude affect frequency? Okay, so we're going to change the amplitude 3 different times. We're going to time the wave period for 1 cycle and write it in the box. So we're going to find the average and use the equation for frequency. The average for frequency is 1 divided by how long it took. So let's do one together. So let's do 0.75 again, just since that's the regular one. I'm going to let that go for a second. I'm going to come over here, 0.75. So I'm going to time how long it takes for one wave to go. And this is how it's going to look, okay? So I'm going to use my timer, and I'm going to use this reference line here. So if I use the reference line, I'm going to bring it down, and then I'm going to use this first green dot right here. So this is the dot that I'm looking at. When the dot hits this line, I'm going to start the timer, and when it stops, I'm going to stop my timer, okay? Now, it's okay that we're doing this in slow motion because the stopwatch goes in slow motion too, which is actually kind of nice. So I'm going to watch one more cycle here. I'm going to hit start, and then when it comes back, I'm going to hit stop. 0.68, okay? So I'm going to do 0.68. Now I'm going to do it a second time because my finger might be a little slow or fast, so I want to take an average. So I'm going to reset it, and we'll wait for it to go one more time around. Start. And stop. 0.67. So that's pretty close. So 0.67. Average would be divided by, add them up, divided by 2, 0.675. Okay. So now frequency is 1 divided by the time. So if I go in, I'm going to do calculator 1 divided by 0.675 equals 1.48. That's all the further. Don't worry about those other numbers. Just to the hundredths place is just fine. So I'm going to type in 1.48. And then I'm going to go to a different amplitude, 1.25. And you're going to do the same thing. You're going to time, see how it goes, and then you're good to go. So this is how we're going to do both of these today. We'll do the second half tomorrow. Get this one filled in and submitted. Thanks. Bye.